Okay, in this example, we're going to be looking at the normal distribution. And the problem that we're going to be looking at is 6.45 from the book. Okay, so there's a lot of numbers in the statement of this problem, but we can keep them straight, and you're going to need to do that on the exam. So in this case, an industrial sewing machine has a target output. And so that's what these first numbers are. It says it uses ball bearings. They have a targeted diameter of 0.75 inches. That's where they want to be. And there's a lower and upper spec limit that are allowed for the size of these ball bearings. So there's 0.74 versus 0.76. That's the lower and upper end. That's what we want to have in the sewing machine. Now, past experience, we get into the statement about the normal distribution. Past experience has indicated the actual diameter of the ball bearings is approximately normal. So we get our normal distribution from this statement right here, approximately normally distributed. That's how we know it's the normal distribution. And the mean is 0.753 and the standard deviation is 0.004. And so we can write mean is 0.753 inches and the standard deviation is 0.004 inches. Okay, so that's the numbers that we're going to put into Minitab to compute probabilities. Okay, now what's the question? The first question is, what is the probability that the ball bearing is between the target and the actual mean? Okay, so what is that asking? What's the probability that X is between a target and the actual mean? And so if we're thinking of the range of values that we could have, we've got a target value somewhere on here. Maybe it's right here. Here's the target. Here's the mean. And it's asking what's the probability that the ball bearing is between the target and the actual mean. So we're looking at a probability between the target and the actual mean. That's what this means. And so X is the diameter, and X is going to be between two values, the mean and the target. I don't know which one's higher. Let's see. The mean looks like it's actually higher, and so it would be less than the mean, and it would be greater than the target, which was 0.75. So what's the probability that it is within that range? Okay, so that's the first probability statement. And we kind of had to work through that slowly, but it's important to know what you're getting a probability for, or you might make a mistake. Okay, so now we can enter in these values into Minitab to compute the probability. So let's go there now. Okay, so we're going to go to graph and look at a probability distribution plot and view probabilities. Okay, we're doing a normal distribution. Our mean is 0.753 and our standard deviation is 0.004 as stated in the problem. Now the shaded area, we are looking at X values. We're looking at a range of probabilities between two X values, so we want to choose middle. And value 1, which is the lower value, is our target, which was 0.75. Our upper value is our mean, 0.753. And so this will give us the range of values to compute the probability. And I'll click OK. And there we have it. The probability that a ball bearing has a diameter between the target and the mean is 0.2734. And that's how I compute that probability. Okay, let's go to the next question. The next question asks, what's the probability that the probability is between the lower specification limit and the target? Okay, so if I'm going back to the example here, I can erase these. The example, and I like to draw a graph to remember what is being asked. Okay, what's the probability that a ball bearing, the diameter, is between the lower specification limit and the target? So that's two values that I'm going to measure from. We'll call it the lower spec limit, LSL, and the target. Okay, and we're asking what's the probability that it's within those ranges. So that's within this range right here that we're trying to compute. So we'll go to Minitab, minimize this. We can open up the last dialog box we had by using this button. We'll go to the shaded area, and in this case we want to look at the lower target value, which, if we go back to the problem statement, we see the lower target value is 0.74 and the target is 0.75. So between that range, let's see what the probability is that the ball bearing is between that range. Go back to Minitab. Lower value is 0.74. The upper value is the target, 0.75. And so what's the probability that we choose a ball bearing at random and it's got a diameter within that range? That's what we're trying to find. And we get 0.2261 as the probability. And you see that it's shaded between the lower spec limit and the target value. Okay? Part C asks, what's the probability that it's above the upper spec limit? And we can get upper and lower spec limits next. C and D will be really easy. Okay, so close this, go back to our probability plot, and we look at the shaded area. The first one was, what's the probability that our measurement is below the lower spec? So let's get the left tail, 0.74. What's the probability that our ball bearing diameter is below this value? Choose OK. And the probability is very small. It doesn't hardly shade anything. 0.00057770 probability that a ball bearing has a diameter below that value, which is good because we want them to be within a certain range, and so this probability is very low. That's what we want to see, but that is the answer, even though it kind of looks strange. Alright, the next one is, what's the probability that it's above the upper specification limit? So that would be a right tail probability, and I need to look at larger than 0.76 because I believe that was the upper spec limit. Yeah, there it is right there, 0.76 inches. So we go back to Minitab. We want to choose right tail, 0.76. We have it entered in already. We get that there is over a 4% chance that we have a ball bearing that has a diameter that's too large. So it's more likely that we get a diameter that's larger than what we're supposed to have in the industrial sewing machine. So that's useful probabilities. Now, part E. Part E says, and this is one of those inverted questions, of all the ball bearings, 93% of the diameters are greater than what value? Okay, I'm going to draw a chart on this one to help out. Erase this. Okay, so if I drew a chart of what's being asked here, I've got a certain diameter that 93% of the diameters are larger than. So I'm going to draw a line here and put x equals question mark. But I know that there's 93% that are larger than that value. And so seeing this chart helps me to put in the correct values in Minitab. And so I'm going to go to Minitab, go to the same chart we were using before, the probability distribution plot under the graph menu. I've got the mean and the standard deviation entered in. Now I need to go to a shaded region. And in this case, recall that I am entering in a probability value. and I want it to return an X value. So I'm going to change what I'm entering in to be a probability. So I select probability. And it will be a right tail because, as we saw, the probability of something being larger than an unknown value is 93%. So I'm going to type in 0.93 and click OK. And you can see that now I've got 93% of the ball bearings are larger than 0.7471 inches in diameter. And that's the answer to part E. Okay? We should have covered most everything that you'll see, and if you have more questions, you can ask me before the exam tomorrow. But I believe that's the rest of that question. Yep, that's the last question. So, good luck on the exam.